We will be doing some problems from the textbook, so I've run off the appropriate pages from the book so you can consult that. And then also there's some extra homework practice that also, I've given you, okay? So let's get our notes out and let's just jump in. Is it a polynomial function? If not, why not? So you are going to look at each one of these, and right now you may not have a clue, so maybe you just take a guess. Do any of those seem to be polynomials to you? A, B, C, D, and E. You think C is a polynomial, and I agree. So what am I supposed to do? Is it a polynomial? If not, why not? It is. That is a polynomial. It is actually a linear polynomial, because if we graphed it, it would be a line. Okay? Anybody have any other thoughts on these? B? D? D is a quadratic polynomial. What would D look like if we graphed it? It would be some kind of parabola. Yep, that is perfect. E is a polynomial. It is a 5th degree polynomial, and we're going to talk about what that looks like. That's part of this chapter, is figuring out how to graph bigger things than parabolas. A is not a polynomial. Can anybody tell me what you think is wrong with it, Jake?
It's a negative exponent.
Yeah, you can't have a negative exponent. Now, please listen to me. You can't have a negative exponent because remember what a negative exponent means.
Imaginary number.
No, not imaginary number.
Fraction.
It goes to the denominator. So this becomes 3 over x to the 15th. And as soon as you put an x in the denominator, you introduce the possibility of having a vertical asymptote, because x could, in this problem, x couldn't be 0. Remember, no zeros in the denominator? So if you have x's in your denominator, you're not a polynomial. Polynomials look like this, okay? They go ooh, forever and ever. As soon as you put one of those in, now you've got an asymptote in your problem, and it, who knows what it does over here and over here, but it can't connect, see? It can't be one smooth flow. All right, so no x's in the denominator, which automatically means you can't have any negative exponents, okay? Now, B is also not a polynomial. What do you think is wrong with B?
Oh, there's a radical.
Can't have a radical, yeah. No fractional exponents, because fractional exponents are radicals. Anytime you have a fractional exponent, you have a radical, and radicals are not allowed. So here we physically see the radical. It would be x to the 4/5. If it were written in fraction form, can't have it. Okay, so bottom line is, you're not going to be a polynomial if you have a negative exponent on your variable or a fractional exponent on your variable, because negatives will put it in the denominator and fractional will put it under a radical. Got it? Okay, that's not too bad. Write the equation of the linear function given f of 2 is 3 and f of 4 is 11. You know how to do this problem. It's written differently. Remember when you do function notation, f of x is the same as y? So this is an x value, and then whatever the answer is, that's your y value. So what does this mean? This means if x is 2, y is 3. If x is 4, y is 11. So I've given you 2 points, basically. I wrote them differently, but that's 2 ordered pairs, and you're gonna write the equation of the line. Find the slope. You've done this before. Find the slope. So I got 4, but I did that kind of fast. Is that right?
Yeah.
Then we pick one of the points. I'll just pick that one. It makes no difference. Pick one of my points and do point slope. So y minus 3 equals 4 times x minus 2. Everybody remember that? Important skill, writing the equation of a line. Now, under normal circumstances, without any specific directions, we could stop here. That's the equation of a line, right? But unfortunately, this says write the equation of a function. So my final answer has to look like this, which means I need to get y by itself so that I can use my function notation. So I'll go ahead and distribute, add 3, so it looks like 4x minus 5. Is that okay? All right, would you try B on your own? You're going to do exactly the same thing. Your points are different. We'll have somebody come up. If you feel like you want to do it on the board, that would be great. Volunteer. Thank you, Jay. When are you gonna be not looking around anymore?
Not till December, pretty much.
December?
It takes 10 weeks for it to do. Is it torn completely? But not. Torn completely, but it's not. I don't have concerns.
My balancer I got.
Wait.
Oh, wait, oh, no, I was not. Different problem. Can I raise it?
Here he goes. Okay. You got a slope of 1/2. Is that what you got?
Yeah.
This is one of those picky little things, kids say functions, so go ahead and make that right. He got 1/2 x plus 1. Is that okay? Alright, so lines are easy, we've done them before. Okay, so now we're moving up to the next step, which is quadratics. So, first of all, do you recognize that 3a is a parabola?
Yeah.
Okay, now, your BFF parabola, remember, is this. Vertex at the origin, opening up. When you start sticking stuff in there, it changes that. So, tell me about problem A. Where is his vertex?
0, 0.
No, not for problem 3A.
3A.
This is 0,
Oh,
0,
no.
but 3A. He's been moved 1 left
Down 4.
and down 4.
Yeah.
So would everybody agree that his vertex is at -1, -4?
Yep.
You can tell from the equation, it's in what's called vertex form, you can just tell the vertex. What does that negative out in front do?
Down
Turns
3
it upside down. And then this line right here is called the axis of symmetry. What would be the equation of that? X equals -1. Your axis of symmetry obviously is going to go down through the vertex. Always going to, as long as your parabola is a function, up or down, it's always going to be x equals, and in this case, -1. So, look at B. Where's the vertex for B?
-3.
3, comma 0. How do I know it's 0? Because there's no number to lift it, right, or lower it. So 3, comma 0, which means my axis of symmetry is x equals 3. Remember, it's an equation. X equals 3. And which way does B open? Up. The direction is the direction of opening. So B is up. How do we know? Because I didn't multiply it by negative, right? They're all gonna open up unless you put a negative in front of them. All right, C, vertex, -3, 10. That means the axis of symmetry is x equals -3. And which way does it open? Up. Now, those 3 were easy. If you paid any attention at all in the last chapter, those 3 were easy. Now they're a little bit tougher because can you still tell you got a parabola for 4A? Yep, I know I got a parabola. And some of you have said, I know it opens down. But after that, it's a little bit tricky. So these directions say, rewrite the parabola in vertex form. Now, vertex form is what we just did in part 3. This is called vertex form because you looked at it and told me what the vertex was. So we got to rewrite this equation. Keep an eye on the time because you probably want to go to lunch. I got to rewrite this equation in that form. All right? So here's how we're going to do it. First thing we're going to do is move that 3 over to the other side. Okay, you with me? Now, I'm going to factor out the -2. First, I move the 3. Please move the 3 first. Then factor out the -2 carefully. And when you factor it, leave an extra space in there where the 3 would have been, but we moved it. Leave a space in there, an empty space. Now we're going to complete the square inside the parentheses. So how do we do that again? Remember, we
Divide
take
B by 2.
half of this, divide this by 2 and square it. So half of 2 is 1, squared is 1. Remember, I'm not concerned about the negative because I'm squaring anyway, so whatever I put here is always going to be a plus, right? Now, here's where you got to be careful. It looks like I added a 1, but I really added a -2, and that's what has to get added on the other side. So you're adding something to the right, you have to add the same thing to the left. Since that 1 got times by -2, -2 is what I add over here. So now I have y plus 1 equals -2. Now, if you did your job, this is a perfect square. What square is that? X minus 1. It always follows that sign right there. So it's going to be x minus 1. And then I'll move the 1 back over. And guess what? I am now in vertex form. Okay? Where's the vertex?
1, negative 1.
1, negative 1. What's the axis of symmetry? X equals 1. Don't just put a number. You have to put an equation. X equals. Because eventually we'll get parabolas that open sideways and their axis will be y equals. All right. Oops. Let's try the next one. All right, so what are we going to do first? Move the 1 over. So y minus 1. Yeah, so let's be careful here and not be, don't go too fast. We're going to factor out a 1/2. And some of you might say, oh yeah, that will be 3. No, it won't. Because what's 1/2 times 3? It's not 6, right? This will be 12. Now, why is it 12? You're right, it's 12. Over here, when we took out a -2, you all said -2, and you were right, because factoring is division. So we did 4 divided by -2, and that's how we got that number. So we need to do 6 divided by 1/2, which is 12. Now, before anybody stops to get confused, just stop and think. If I multiply this back, shouldn't I get this?
Yeah.
So 1/2 times x squared, 1/2 times -12. If you don't get the right number, just change it. Find the right number, because you need it to multiply back to give you 6. All right, here we go. What goes in the blank? 36. But don't add 36 over here. What's going to get added over here? 18, because you need half of 36.
Wouldn't it be minus 18? Or, no, never mind. Never mind.
Whatever it is over here is what it will be over there. Okay? It's an equation. Girls, we okay? You got it? Okay. So, over here I got y plus 17. What do I have here? X minus 6 squared. Beautiful. And I'll move that 17 back over. And my vertex is where?
6, -17.
6, -17. My axis is x equals 6. And my direction of opening is up. Which you could have answered that right from the beginning. I didn't, but you could. All right, now we're going to go to lunch here in a minute. I want you to get started on C. On your own, see what you can do with C. Don't freak out. We're going to skip the first step, right? Because there's no number to move over. So you're just going to jump in and start completing the square. So what are you adding in here to make a square? Four?
So you had
But the 4 is really a 12 on the other side?
Wait, what did you do? X squared in there. If you can pull out a 3x.
You don't put X.
Yeah, you gotta complete the square. We're not factoring this problem, we're completing the square. So we take out just the coefficient. And my square that I made
X plus
is x plus 2. What's my vertex?
-2,
-2, -12, meaning my axis is x equals -2, and of course I open
Down.
up.
What am I saying?
I don't know.